In this video, I'm going to tell you about what is a service mesh and how and why this is very important in any production level Kubernetes cluster. So we already know how to deploy microservices over a Kubernetes cluster. Application consists of multiple microservices, so they all talk to each other, and they give you the job or the output that the application is working properly. But there are certain issues in that scenario which you generally learn at the CKA level, that the microservices are talking to each other, right? But the communication within the cluster is not secure. Means the microservices, if they are talking, let me try to give you an example here. I will use the same coaster which I had used in the. So we have, say, two microservices here, let's say. So these two microservices are running on a Kubernetes cluster. There are a couple of things. The developer will be responsible only for the business logic, means the application code, and the communication between these two microservices. Now they might be running on the same machine or they might be running on different machines. The communication between these two microservices or all the microservices is in plain text, which is a problem. Second, in no way I can control that which microservice will talk to which microservices. By default, any microservices can talk to any service. I might not want that. How to control the communication configurations? How to control the security? The communication is in plain text. How I can have traffic splitting or traffic shaping can be done. How to collect metrics and tracing of each services. How much load this say payment gateway service is getting, right? How much load we are getting on add to cart service, and which service is then communicating with which service. There is no way you will be able to find out if you have a huge application running hundreds of microservices. So how to monitor it? How we can have security, right? How we can have communication configurations? How we can have a TLS configured or a encrypted communication configured between the services? How you can have like tracing and logging and all those things. So the solution is the service mesh. So names like Istio, Linkerd, these are the commonly used microservices. So what I'm going to show you is what will happen if you don't use a service mesh for an application, and how a service mesh gives you a peace of mind and gives you a lot of things which you cannot think of without the service mesh. So let's start doing this video.
So the first thing we are going to do is we'll be creating a Kubernetes cluster. So I'm using Linode as my service. So just create a cluster here. Creating a cluster on Linode is very easy. I had explained it earlier also. The best way to create a production level Kubernetes cluster is let someone else do it for you. So my name of the cluster is going to be networknuts. I choose a region which will be near to me. I choose Mumbai, India, and the version anyone. I choose 1.21 n-1. Then which hardware you wanted to use? I can use say 8 GB RAM. This one is good. So 3 nodes are good for me. I can have 4, but fine, 3 will do the job. So that's a monthly billing here. Just leave it. So it's the fastest way, one of the fastest way of creating a Kubernetes cluster. It won't take much time. Then I will be accessing it from my local machine or my virtual machine, which is I had already created. So I have this virtual machine with me, which is here, workstation. This is a Ubuntu box. So I'm going to access it. That Linode cluster, a Kubernetes cluster on Linode, running on the cloud. I'm going to access it from here. So I will be doing a SSH from my base machine, so it will be easy for me. So IP address is 192.168.1.14. Okay, you might be using different tools to SSH to machines like PuTTY, etc. I use MOBA Extrem. So that's my IP address. I hit here, supply the IP. I like it. It's very easy. This is it. It's the same machine which is here, but it will be easy for me to do a copy paste. So I access it from here. That's the machine. So let's check it out. Yeah, they are provisioning it. It won't take much time. The moment the Kubernetes is installed, I will be getting a kubeconfig file which I will download and use it. Just wait for a minute. It won't take much time. And so this is what I need on this machine, that the kubectl should be installed, right? So I have kubectl already installed here, and this machine should be able to go to the internet. So if I do a dig of google.com, yeah, I'm able to go to the internet. That is one requirement. Then I can do like kubectl install. So I have kubectl already with me. So just make sure that it is installed. I can use version, press enter here, right? The kubectl is already installed. So if it is not, you can use the snap, so sudo snap install kubectl -- classic. I had already done this. It is already installed. Perfect. So that is it. Okay, now it is cool. So I have the kubeconfig available here. So my cluster is running on Linode. I just copy it. I just need this kubeconfig file, right? So we all know the trick. I just copy this file and I go to my machine. I create a .kube folder. I go inside the .kube folder. I create a config file and I paste it here. That is all I have to do. Paste it, save and come out. If everything is right, I should be able to run the kubectl get nodes, and this should show me the machines which is running on Linode. Yeah, perfect. Not ready. Might be will take some time to check it out. It is still provisioning. Yeah, now it is coming up. I can do a refresh to check it out, or just do it again. Yeah, one is ready. So we have to wait till they are ready. That's the easiest. It is offline. I can do a refresh. Let it run. So yeah, all are running now. So if I go back and check it, I should be getting it. Yeah, ready. Now, before we go deep dive into understanding what is the service mesh, because this is what we are going to learn. What is the service mesh? Let us just simply deploy our application. We will be deploying a microservices, say a web portal selling some products. So you can get a sample product from this Google Cloud Platform microservices demo available on the GitHub. So you can go here, and I go to the releases, because we are not at all into application development, right? So this is a file. I copy it. Just copy this whole. I'm not going into this, just copying it. It contains a lot of microservices, lot of services which are combining together, working together to give me an application. So I copy this and I create a file here, Kubernetes -deployment, any name .yaml. Okay, it is there, right? I can have it. So the file is there. I had copied it. Now save and come out and run it, right? Kubectl create -f Kubernetes deployment, right? See, so it is generating a lot of deployments, generating a lot of services. So if I show you here, kubectl get pods, I'm getting these pods, right? Just wait for a minute. We have to wait till everything will come up, and it will be creating some services also. Yep. So we can access this application on the front end IP address. That's a load balancer IP address. So because we are running it on Linode, so the IPs are available. Yeah. Just wait for a minute. We have to wait till everything comes up. So currently only the business logic is there. See, one by one means every pod is running a single container, right? Every pod is running a single container. First we will just install our application, then I will discuss the problems associated with this. This is what we learn in CKA, that fine, we will be given some application and we will deploy it. Yeah, everything is working now. Just this one need to be running. It should be ready soon. Once it is ready, I will check the services. In the meanwhile, kubectl get service. Yeah. So this is, so if everything is working fine, I should be able to access this application, whatever this application is, on using this IP address. Let me see the port. Yeah. So all good, guys. It took around 90 seconds for everything to get online. So I get kubectl get service. I copy this IP address, right? And I open the browser on my machine. I should be able to access it, huh? So that's my machine here. I do a paste and go. Yeah, see, this is it. So my online boutique, some actual website is running. So it contains a lot of microservices. One is the cart, right? So if I click here, it goes to add to cart. So the cart is coming, then the payment gateway is working. You may also like this actual application is running on the Kubernetes, right? On my Kubernetes cluster. Now, what's the problem? What's the problem in this? So we have a lot of microservices. If I go here, these are all the microservices which are communicating with each other and giving me the application, like here, right? They're giving me this application. There are a lot of problems associated in this scenario. This is what you learn in CKA, right? But here we are deployed an actual application and we are able to access it. Now we will talk about the problems here. So I will use Microsoft Whiteboard. So what are the problems? So I have got a lot of services running. So we know the application consists of microservices. So these are the microservices. So some 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 services are running together and giving you this web application, whatever it is. What's the problem? The challenges are, so we have a lot of microservices, right? So, and we have a lot of pods. If I show you, we have a lot of pods also. These are the pods. These pods are running and they are giving you, they will be communicating with each other, right? And the business logic is there. See, developer's job is to just define the business logic into the application. So what it is currently doing, so we have this online portal which we are selling some products, online boutique. So what's the problem in this? The problem is I have got a couple of pods, right? I've got a lot of pods, some 6, 7 pods are there. I don't like this when it goes like this. So a lot of pods are there. Say I just draw these much, right? Every pod, so this is a pod. You have to be patient for this to understand what is a service mesh and what are the problems if we don't deploy the service mesh. And every pod is running a container, right? So every pod is running a container. Let me put it in the green color. So one pod, one container, right? And this contains the business logic. Only the business logic is there, BL, the business logic. So this is the microservice, right? Business logic, business logic, business logic, and business logic. So they are talking to each other, right? All the pods, they are able to talk to each other. So might be if I am a user, right? User might be hitting the front end application, right? The load balancer, and then the load balancer will taking it to the cart, the your main site, then that is adding to the cart. This might be the main portal, right? This might be the portal, this might be your cart service, this might be your payment gateway service, and it might be connected to some database also, but this is how the things are. So this is currently what is happening. What's the problem? The problem is very simple. A company can have a kind of a firewall. I might have a firewall here. The company will be deploying an edge firewall to secure the cluster from the outside issues, right? So we might have a firewall here. Some rules are here. This is a corporate firewall. So any like suspicious traffic, it might happen that if someone is trying to do some nonsense activity, the firewall will be able to pick it and will just block it here. So, but the firewall, it protects me only from the outside. Internal communication is not at all secure, guys. Right? In this case, every service can talk to every other service, right? So this is one problem, and the communication between the services is in plain text. So this is plain text. This is plain text, right? This is plain text. So one service is talking to each to other, and the communication within my cluster is happening in the plain text, and every service can talk to every service, right? Every service can talk to every service. So this is a bad thing, huh? Every service, sorry. This is the challenge. So the communication is plain text and anyone can do. So what to do? Apart from the business logic, logic, I need certain things. I need the code for communication configuration. What you need? This is what I need, right? I need the code for your communication configuration, means which service is allowed to talk to which service and which service is not allowed to talk to which service. Something like SE Linux, which controls the services. So I need a communication control, right? Communication configuration, like, or say controls. I need this. Second, I need security logic. Some security need to be there, huh? Security logic need to be there. You might also need to configure metrics, that how much load is getting to a card service, right? How much request is coming to card? How many people are adding the product in the cart but then not buying it? I might be able to, so metrics need to be collected. Metrics and tracing need to be done. And I might be interested in the logics for the retry attempts. Might be one service is not able to talk to the other service, so how many times I should do a retry, what to do. So these things need to be added apart from the business logic. Business logic is being added by the developer. So the developer guy has created the code for the business logic, but now I am asking the developer to do this all. Wow. So developers will go mad, totally crazy, right? So they will now, if I tell the developer team to do this also, so the point is that will they be focusing on the business logic, the actual application, or they will be talking about the security aspects, the metric and all the things. So and then if I add these things, let's suppose these 1, 2, 3, 4, if I add these 4 points in the business logic, means in the main image, then it will increase the size of the image. It will add the complexity. What to do? The solution is service mesh, right? So what service mesh does? Service mesh act as a sidecar containers or a sidecar pattern, what they use. So what they use is this. So the solution for all this is your service mesh with a sidecar, service mesh, right? Service mesh is the solution. So what it does? Now think of it. I will ask the developer, say the green team is the developer team, right? The green guy. I will ask him, hey dude, he is the developer. Developer, you should only write the code for the business logic, right? The actual, this portal means this all. Just you keep on developing this thing, the UI, the connectivity things and all, right? You should just focus on the business logic, BL. If I hire another team, I will ask a third party, right? If I ask a third party, this is a third party. If I ask a third party, hey, you should write the code for communication configuration, right? Communication configuration. You should write the code for security of the application. You should write the code for metric collection, tracing, and other things, right? And you should write this code. And then I create a pod. I will have my pod which will have the business logic container running here inside it. And it will also have a sidecar container running inside every pod containing all these things. So this is acting, so this is the pod. This one is my pod. That's my pod, the whole pod. The pod contains microservice, right? This is the microservice, right? Actual application, microservice, or the business your business logic. And this, with all these like communication configuration, security code, metric, tracing, everything, this will be acting as a proxy or a sidecar container. And someone else is responsible for writing all these things. That is what the service mesh does. And the best part is that this thing is being injected in the control plane, in your Kubernetes control plane. So I need not to configure or do any changes in my application. That's the best thing. So what it does, so it secures your services, right? That is what the service mesh does. It secure your communication. I can have traffic splitting things being coming onto it. Now another feature of the service mesh is the traffic splitting. And the best part, as I'm repeating myself, that this service mesh is added in the control plane, right? So I need not to do any changes in my application. Try to understand this. This is your control plane or your manager, right? And these are your pods. These are your pods. These are your pods. Every pod is running a proxy, number one, right? Every pod is running a proxy, the sidecar, and a business application, right? The green one is the business or the microservice. Business logic. Business logic means microservice, actual code. So every pod will have a business logic container. And every pod will also have a proxy container, which is being created by the service mesh. Now the best part is that, and these proxies will be able to be talking to each other now, right? Services won't be talking to each other directly. They will send the communication to the proxy, and the proxy will be communicating on their behalf, securing all the things and everything. And this your service mesh, that is your control plane. This service mesh is actually a part of the control plane, right? Like this, something like this. So this become automatically injected, right? This is your network layer. This is your network layer. So this got automatically injected. So proxy is a part of the control plane. It will be automatically injected in the applications. I need not to do anything extra. I need not to change my code. I just use a service mesh, and the service mesh will automatically inject one proxy container which has all those codes for security and traffic splitting, metric collection. That is a part of the proxy. This is how the things works. So that makes my life easy. And one of the very important thing that the service mesh does is they give me a very interesting feature of traffic splitting. It is used in the Canary deployments. Traffic splitting. What is traffic splitting? Let me explain this. Let's suppose that we have a payment gateway service here, right? So when we click here and we add to the cart, right? We do the place order. So the payment gateway will be coming up here, whatever. So now might be we had updated the payment gateway service. So currently, let's suppose we are running version 1 of the payment gateway service. So we have a payment service. I call it payment gateway. So we have a payment gateway service. Say currently we are running version 1 of the payment gateway service. Now developers have created a newer version, and the newer version 2 of the payment gateway is available now. Now, though the developer would have taken utmost care to make sure that there is no bug and nothing, but you can't be sure, You can't be sure that there is no bug, and they had deployed this version 2 in the production, right? They had deployed version 2 in production. It's a microservice. They had deployed it, and let's suppose a bug got creeped in, right? They just skipped this bug. It can happen. What will happen now? Now, whenever the customers are doing a checkout, the payment gateway service will fail, right? Rest all the complete application is working properly, but whenever they are doing a payment gateway checkout or a checkout, they are trying to give you the money, it is failing. It is a huge loss to the company. So I don't want this. So the service mesh here, in our case, it's like Istio. So Istio it is actually Istio. Istio. We pronounce it as Istio. So Istio has a very interesting feature of traffic splitting. What I can do with the traffic splitting? Oh, I had already mentioned it. Suppose this is the version 1 of the application, right? Some containers are running of the version 1 of the application, and I have one is the version 3 of the application. I can do a traffic splitting, that my service is there. So web service is there running, web service, right? So I can configure it that, okay, say 95% of the traffic should go to the version 1, right? And only say 5% of the traffic should go to the version 2. So 5% traffic is going here and 95% of the traffic is going here. So we can see whether it's working properly or not. So this kind of things can be done with a service mesh. So our service mesh, which we are going to use, Istio, is totally capable of doing this. So this kind of thing where we are splitting the traffic, this is also referred as Canary deployments. Canary deployments, right? Canary deployment. So we are capable of doing it. So, but how it works? So, like Istio deploys a sidecar container. I had already told you that sidecar container in the Istio, is known as envoy sidecar container. So what happens? There is your business logic, right? This is your business logic. Every pod, business logic is the code which is written by the developer, right? Business logic, they will deploy a envoy pod into it, a sidecar container. This pod will be deployed. Container will be deployed, envoy container. It contains a lot of services. I'm not going into that, but this will do all the things for you, right? And this is a part of the data plane. I had already explained that. So I need not to touch anything in my application. It will automatically collect metric. So this is already configured to collect metric, right? It will secure your communication within the services. They call it mTLS, mutual TLS, right? So mTLS will be configured now. So earlier, where the inside traffic was totally plain text, now the service to service communication will be encrypted. It is capable of collecting metrics. Your communication configurations can be done, right? Your traffic splitting can be done. But for that, you need to go through the Istio documentation and read more about it. So this is what the purpose of any service mesh. You will never see any production level deployment of Kubernetes without service mesh. So common service mesh which are available in the industry is the Istio, which we are using. Istio is one of the, and Linkerd. There are other also. So Istio is one of the most popular one. So let's now integrate the Istio in it. So my application is running, right? Now we have understood it. What is the problem? The problem in this, that the communication within the services, right? Communication between these services is in plain text. And I cannot have the traffic splitting and all those things done. I don't have metrics. If I wanted to see how much load is coming onto each service, there is no way I can find out. I had to integrate Prometheus and Grafana separately. That is where the service mesh comes. So the first thing that we are going to do is install the service mesh. So we will be using Istio. So if I search for here Istio, it is being created by Indian. If you go to some Varun something, let me show you. Istio is being created by Varun and some someone was there. Who created Istio creators, huh? So yeah, Varun Talwar and Louis Ryan of Google, they created this. So it's a proud moment for being Indian. Perfect. Though we are just learning it, but yeah, it's a proud moment. So so I go to Istio once again. I need to download it, right? Go to Istio. It's very easy. Just read the documentation, right? Setup, getting started, download and install. So just run the script. It will automatically download the folder for you. So okay, so we go here, copy this, go to my machine, paste it. Beautiful thing is that it gives you the steps also, what to do. Wow. So Istio 1.13.0 download successful. The first thing that you need to do is you need to export the path. So it has created a folder here, Istio, and here inside this I have got the bin, right? This is the bin. That is where the binary is. So my Istio commands won't work here because I need to first put it in the path, right? So this is the path. They had already picked it. So I just copy this. To make it permanent, you have to put up an entry in your bash rc or etc profile. What? Right, done. Then do a pre-check. It's very easy stuff. Done. It's checking here. Perfect. So now I need to do an installation. How to do installation? Even that is mentioned here. So go to the Istio, just export the path, right? And then do this etcoctl install. That's it. So if I go here and I paste it, it will install the things for me. Let's do a yes here. So might take some time, but not that much. Okay. It also gives you an ingress gateway which allows access from outside world. I'm not at all going into the details of Istio, just trying to explain to you the benefit of service mesh. Right. So if I check it out, I give the command here kubectl get namespaces. I have this Istio system. So if I give a kubectl get pods in the namespace Istio system, I should be able to see the pods. Yeah, these two pods are running. Now what's the benefit? What's the benefit? Okay, my one application is already running there. So kubectl get deployments. Let me remove this, right? I'm going to remove all these deployments first. So let's create it again. Kubectl delete -f Kubernetes So my everything is gone. We are fresh with the Istio installed, right? So Istio is there. How will I tell my application that you should use Istio? It's very easy. Istio says that every application will be running in a namespace. All you need to do is put this label on that namespace. So I will be using the default one. I copy this and I go here. So that's the second step, that you should label the namespace. So if I check it out, kubectl get namespaces -- show labels. I don't see my label here, so I paste it here. Sorry, I go back. Just read the documentation, guys. Very simple stuff. Paste it here. So I'm making a label on this. So if if I get the namespaces, I can see my label here. Istio injection enabled. That means if now any application which is trying to run in the default namespace or any namespace of your choice will have the Istio proxy sidecar containers injected, right? So I run that application again. See, I have done no changes in my application. I didn't touch this application, right? But this is going to run in that namespace. So now see it here. So that means one more container should be running in those. So earlier, if you have seen, if we have got only one container per pod, one by one. So now every of these services should have two containers running, right? One is the sidecar container, which contains the logic for matrix and mTLS and everything, and other is your business application. I hope you still remember that drawing. Where was the drawing? Like, right? So let's go back. So I go back here and I created. Done. Wow, so fast. So if I check it out, kubectl get pods, see 2 by, right? So very soon I should see 2 by 2. It won't take much time. Yep, couple of them are already running up. So now every business application, every microservices has got that sidecar pod injected, right? So this is what happened. You have created the pod only with the business logic, right? Business logic. But because the Istio is installed, right, already available, so Istio has injected a proxy, a sidecar or a proxy pod inside the pod, inside your business pod. This contains the code for metric collection, traffic shaping, mTLS, security, communication controls, everything. And now if this business application wanted to talk, so he should be talking to the proxy, and then the proxy will be going out and will be talking to the other microservices, right? So every pod will have the proxy installed, and the communication will be happening at the proxy to proxy level, right? And this is going to be secure using mTLS, mutual TLS, which was not there earlier, right? This code is being injected. Now let's check it out. I hope it will be done by now. So if I again, perfect, 2 by 2, wow, I can check it. So if I go to this one and I give the command here, kubectl describe pod, this, so if you scroll up, you will see a Istio pod init container. See, Istio init. It is using this Istio proxy. So this one more container, is running inside the pod, right? It is running on this port, whatever, some compute is being given. It's doing what he's supposed to do, but right, STOD is the main service, the daemon which runs in the control plane. So every container will be this. So what's the benefit? If I go here, kubectl get service, if I again hit on this, so now I can be sure right? That the service to service communication is encrypted, number one, and I can enable metric and all those things there. So just a minute, I have to go here. Oh, sorry, I have to copy it first. So I copy this, go to this. This will not work. I have a different IP now. Paste and go. Not right. So this is working, but and I am sure that my service to service communication is secure. Earlier it was in plain text. That is what the your service mesh does. So in my case it is the Istio. Now apart from this, we had learned it, so fine, my communication is totally secure. Second part is, how can I do data visualization? I wanted to see, I wanted to have the Prometheus and the Grafana and everything running there. So if I show you the pods in Istio system, Istio-system, I have got two containers, right? Two pods are there. So if I go in my folder here, that particular package also gives me the, I go to the samples, inside the samples I go to add-ons. So see here, there is Grafana, Jaeger, Kiali. Kiali is one of my favorite service. It shows you how internally the services are communicating, Prometheus and all this. So I can install everything, right? That's my path add-on. So what I do a kubectl create -f Istio sample add-on, right? So it will install everything. I just give the folder name. Wow. Now it has created a lot of things for me. If I again see the pods in the Istio system, see Grafana is working here, Jaeger is working here, Kiali is working here. So what they do, let them run first. Let them should be one by one. Yeah. Now it's a time to do the data visualization. See how much benefits these service mesh gives you. You cannot think of working in an enterprise with hundreds and thousands of services running without using a service mesh. So just a minute, Kiali is supposed to be active very soon. So you might have to learn these things separately if you wanted to dig deep into it, like Kiali and Jaeger, Grafana and Prometheus. I'm pretty sure you are aware of this. Yeah, one by one. Now, I wanted to access the Kiali dashboard or the Prometheus dashboard. Very simple. Because it's running on a different machine. So what I need to do, I need to go to my console. Right, that's the machine which I am doing SSH. I will show it to you from here. And that's the machine. I need to export the path. So all these things are here. Where it is? Yeah. I just copy the path part, because that is not permanent, right? I have to copy it from here, or I can write it here. Yeah, not here. Where is the console? Yeah. Okay, I'll write here. It's not a big deal, right? Because it will be difficult for us to copy it from there. So I simply copy that export thing, so that we will get it. Your stoctl command will work. So I write here export path, and my sto is here, right? stoctl bin. I need to remember this location. That's my path. So I just write here export path equal to present working directory, right? And then stoctl. I need not to get this stoctl bin, right? Wait, bin, and then the actual path, whatever the original path is. I don't want to remove that. Now my stoctl work, right? Yeah, stoctl. Now I wanted to see the Kiali. See how beautiful the Kiali is. So all I need to do is that, because I need to access it from the browser. So that is the only reason I'm coming here. So I just need to give a stoctl dashboard Kiali. It does like it configures the port forwarding on the local machine, and see, here is the Kiali. This is a service, a very interesting service. So we have got a lot of microservices running, right? I have got all these services are running, kubectl get services, and I've got a lot of pods running, kubectl get pods. How the communication is happening, which service is trying to talk to which services, how much traffic is going on. I will be able to see everything from Kiali. So this is it. I've got 12 applications running here. See here, right? App name, it is, you can search here, add services, cert name, all this. Interesting is the graph. You go to the graph in the default namespace, see, visualize version graph. So these are all the services. Wow. So you hit on the load generator, it goes to the front end external, right? And you bring your mouse there, it tells you that this is the service which is doing it is in the namespace. NS is namespace default, the service is front end external, right? And if you click, just like hover your mouse here, service is front end. It goes to the front end latest, then the front end is communicating with the add service, it is communicating with the CSRT and all this. Wow. So how the microservices are interconnected, right? And how they are working, you can see it with the Kiali. So I can have different, say, app graphs also. You need to explore it, guys, right? Separately. You can also see say the request, I wanted to see the traffic distribution. So click here, see how much traffic is going. There is no way you can do it with a Kubernetes. So 88% of the traffic is going here from this to the cart service, right? So a lot of things are available here from edge service. So the load balancer is distributing, 49.3% is going here, and approximately 50.73% 0.7 is going here. So Kiali gives you all these things. Very interesting. So, and see, all these are just available just after installing the service mesh. So you cannot think of any enterprise running a Kubernetes without service mesh, right? You can see application, workload, services. You can even change the like our Istio configurations here. This is what you have to learn separately. I'm not discussing this in this video. Wanted to show you the actual feel that how the things will be working. So in the same manner, I can have a dashboard for Grafana. So we have the Prometheus installed, right? Grafana installed. So I can have dashboard for that also. Very simple. Okay, I'll open one more terminal here, right? I just need that export command again because it is limited to this particular. I paste it here, and all I need here is I have to do is stoctl dashboard Grafana. Okay, it's running. There is some problem with the IP. So if you see here, I had just given this command here, stoctl dashboard Grafana. After specifying the path, it will open up like this. And using the Grafana, I'll be able to monitor all the things, how the things are going, which particular service, say cart service. So loads and everything will be coming up here. So Grafana helps me in viewing the metrics, which is being automatically configured by the service mesh, right? Istio in my case, and the Kiali is also working, which is giving me a visual graph of how the services are communicating with each other. So if I go here and give the command Kiali, so Kiali works here and shows me the graph. So everything is working properly, and I will be able to see a lot of things, app services, and how the things are working, which service is talking to which services, how the traffic is moving up. So this is the importance of the service mesh. You cannot think of a production running without integrating the service mesh. Obviously, you need to learn additionally to configure the shaping, to configure the traffic splitting policies and all that. but I hope I was able to give you a clear idea about what is service mesh and how to integrate it. This is something that we normally teach, and we wanted to share these additional things apart from the official curriculum of CK. So it is not a part of CK. It is not a part of CKS. CKS, yes, we talk about a bit about the service mesh, but not that much. So that is something extra I wanted to share. I hope you have liked it. Feel free to share your reviews, and I'll see you soon with some newer topics. Thank you very much, and don't forget to remove the cluster from Linode, else you'll be billed unnecessarily. Thank you. So we have this Kiali magic working up here, and the Grafana also working up here, right? Everything is coming up here. All the things pre-configured, how much traffic and everything. Thank you very much. Take care. God bless.